functions and increasing, decreasing, and all that. So I want you to solve the inequality x minus 4 over 2x plus 1 is less than or equal to 0. I'm going to say write your answer in interval notation. Now keep in mind, what does that mean to solve the inequality, just in case you forgot what that means? So if I ask you to solve an equation, you give me a list of all the values that satisfy the equation, right? Like if I have like x minus 4 equals 0, let's say x minus 3 also, you would tell me the solutions are x equals 3, x equals 4. If I ask you to solve an inequality, you again give me all values of x that satisfy the inequality, but typically that's going to be an entire interval of numbers, right? So you need to give me an interval that expresses all the x values that satisfy the inequality. I'm going to give you about 3.5 minutes to do this. The lecture videos that were due today actually did cover nonlinear inequalities. So maybe if you watch those videos, you should have already reviewed this, but we're going to review it again anyway. Set up a little timer. When you are done, you can feel free to put your answer in the chat because I'm not going to tell you whether you're right or wrong. But then I'm going to use that in the poll answer. And if you see that your answer is already in the chat, you don't have to rewrite it. I'm going to use those answers to make a poll. Okay, so I already see some answers in the chat. So if you don't see your answer in the chat and you want to kind of volunteer an answer, you can put that in the chat. If not, I'll kind of take these answers and some of the answers from the previous lecture and put them into a poll. So it looks like so far we have the following choices. I'm just going to write them down in the order I see them. So we have this choice. All right, don't repeat. Looks like some of those are repeats, so try not to repeat it. Just so. Okay, I can only have 5 choices. So if you don't have one of these choices, you can type your choice. If not, I'm just going to leave it at that. And E is going to be none of the above. Now again, I'm not saying whether the correct answer is here or not. The answer could be none of the above. All right, so I'm going to do a poll for A, B, C, D, E. All right, just 2 people have not actually answered yet. I'm just going to wait just a few seconds to give you a response for that. Okay, so we have 37%, 32%, 5%, 11%, 11%, and there was one person who didn't actually respond. So again, we see even if you're not sure what the correct answer is, we can again see that the correct answer got at most 37% of the responses, right? So I just kind of want to reemphasize again that it's okay that you get things wrong. A lot of other people get things wrong in the class, right? Whatever you find difficult, other people find difficult. So never fall into that pitfall of thinking, "Oh, I'm stupid. I'm the only one who doesn't get this." That's never true, right? You're all in this together. Okay, so the correct answer is actually choice A. So it actually was the most commonly chosen answer. So let's actually go over this full detail. So first, I kind of want to point out why the inequality is so much more difficult to do, like why this is a tricky problem. So for instance, what if this were an equation? If this were an equation, this would actually be really, really easy, I think. Right? I hope you think that too. So for instance, if I asked you to solve the equation x minus 4 over 2x plus 1 equals 0, what would you do to solve this? Okay, Lawrence says multiply the denominator over. Okay, then multiply by 2x plus 1. Multiply the denominator. Good, right? Just multiply both sides by 2x plus 1. All right, then group like terms, and right, solve it like normal, right? But all of you have the right idea, right? You want to get rid of the denominators first to kind of make things simpler. In this case, the 2x multiplied by 2x plus 1. I said this is actually really easy because obviously if I have 0 on the right-hand side, I stay with 0, and then I end up with x minus 4 equals 0. So I get x equals 4, and I'm all done, right? Why does this not work for an inequality? So let's see what happens for the inequality. So I'm going to do the same exact strategy. Right, I'm multiplying both sides by 2x plus 1. Again, my 2x plus 1s cancel out. I get 0 on the right-hand side. Then I get x less than or equal to 4. And I can write this as interval notation. I can say, aha, that's negative infinity to 4. Or you might actually be even careful about it and say, well, actually, the original, that interval includes negative 1/2, and negative 1/2 would make this denominator 0. So I actually should, at the very least, get rid of negative 1/2, right? So I'm going to say negative infinity to negative 1/2 union negative 1/2 to 4. That's what I'm going to put as my final answer. But it's wrong, right? The correct answer, as I've already said in the very beginning, the correct answer is just the interval negative 1 to 4. Right? For instance, if I were to, like, I know that this is not the correct answer because, for instance, if I were to plug in negative 1, I'm claiming that negative 1 solves the inequality. But if you put negative 1 into this original inequality, you get negative 5 over negative 1, and that's actually positive. Negative 1 does not satisfy the inequality. So something went wrong. So can someone say what went wrong? Why does this strategy work for the equation, right? All good for the equation, all bad for the inequality. Why does the same strategy not work for the inequality? To give you a bit hint about that, what is the strategy? The strategy was multiplying both sides by something. So think about what that means for an equation and inequality, multiplying both sides by something. Cannot have the denominator be equal to 0 in an equality. You're correct, Lauren. I also can have the denominator equal to 0 in an equation, but I've actually already accounted for that, right? For instance, when I looked at the equation, I've already said, okay, x can't be negative 1/2, but that was already implicit when I said x is equal to 4. For the inequality, I've taken out the negative 1/2. So I've actually already accounted for the fact that my denominator can't be 0, right? Because I've kind of excised negative 1/2 from the solution. But even after doing that, I still get the wrong solution, right? I still get all of these values in this first interval. So what went wrong? I mean, think about it this way. I'm multiplying both sides by something. Do you know, do equations and inequalities act differently when you multiply both sides by something? Do we have a special rule with inequalities, for instance, about multiplying? Yes, when it's negative, exactly. Um, so when I multiplied both sides by 2x plus 1, what happened here was, notice that the inequality did not reverse direction. So if the inequality did not reverse direction, I was implicitly assuming that 2x plus 1 was already a positive number. Right? So that's why this interval should not be there, because I already put in the assumption that x was bigger than negative 1/2. So this first interval should not be there. Now, if you want to do this properly, you can do this in a few ways. So one way is to actually do the two cases. You can say, okay, I'm going to do the case 1, 2x plus 1 is positive, so the inequality won't reverse. And then case 2, 2x plus 1 is negative, so in that case, the inequality will reverse. And I'll solve them separately and then combine the solutions. But that's really annoying, especially if you have a lot of factors in the denominator. For instance, what if I added another factor and another factor? You would have cases for each of these, right? Positive or negative, positive or negative, positive or negative. So I'd have two cases, two cases, two cases. I would end up with 8 cases total. That's just a lot of work. So does anyone remember how we actually do solve this inequality? And while you're thinking about that, I'm just going to write the note here. This is wrong because, so this gives wrong answer. since if 2x plus 1 is less than 0, the inequality should reverse. Okay, so can someone say what technique do we use? Can you describe in a few words what that technique is? You might have actually, the technique or the method for solving such an inequality, you actually might have been given a special name in pre-calculus or algebra. Solve for the zeros. So solving for the zeros is one of the steps, right? I need to set the numerator equal to 0 and set the denominator equal to 0 separately. That's the first step of this method. Does that kind of jog the memory of everyone else? So I would say, okay, x minus 4, x equals 4, and x equals negative 1/2. Right? I get those two numbers. What do I then do with those two numbers, right? What is the general method that I'm doing here? Put them in a line graph. Find 3 values to test on a number line. See what some other people are saying. So testing. Let's give you guys a few seconds. For anyone who's typing, let's give you a few more seconds to type out what you were going to say. Maybe it's second thoughts. Okay. But all of this is correct. Good. Everything everyone said was correct, right? We solve for the zeros. We use a line graph. We test these lines. So I'm just going to call this the sign chart method, right? So you solve the inequality. We use a sign chart. So the first thing we have to do is, as was already noted, we first find our cut points. So first, let me just rewrite what is the original inequality. The original inequality is x minus 4 over 2x plus 1 less than or equal to 0. So to find the cut points, what you do is you set the numerator equal to 0, and I get x equals 4. And then you set the denominator equal to 0, and I get x equals negative 1/2. So those cut points now get marked on our number line. Now I'm putting a hole here for negative 1/2. Negative 1/2 absolutely does not satisfy the inequality because it makes the left-hand side undefined, right? So negative 1/2 cannot be included. Then I include here 4. And like a few of you have said, you find values to test, right? The nice thing here is very powerful method. These two cut points divide the number line into 3 separate intervals, right? Negative infinity to negative 1/2, negative 1/2 to 4, and 4 to infinity. And the very powerful statement we can make is that the inequality has one truth value on each of the subintervals. What does that mean? It means that I just need to choose one value from this entire interval, check the truth value for that one value, and that's the truth value for the entire interval. So it's a very powerful method. So I'm going to choose, let's choose easy numbers. So in this interval, I'll choose negative 1. Here I'll choose 0, and here I will choose 5. And now let's just check. What are the truth values? So for negative 1, looking back, the inequality is at the top of the screen. So I get negative 5 over negative 1. That's greater than 0. So the inequality is false. For x equals 0, I get negative 4 over 1. That's negative 4. That's less than or equal to 0. That's true. And then x equals 5. I get here 1 over 11, and that's greater than 0. So the original inequality is false. I also need to check the cut points themselves. For x equals negative 1/2, obviously the whole thing is undefined, so false. For x equals 4, I get 0 over 9. That's 0, and that is less than or equal to 0, so that's true. Let's just put a little highlight on them. So looking back there, so x equals negative 1 had false. So the entire interval, negative infinity to negative 1/2, every single value in that interval will not satisfy the inequality. It's false for the entire interval. It was true for the middle interval. It was false for this interval. It's false for -1/2. That's true for 4. So now our sign chart kind of tells us everything. So what is my final answer here? I'll just collect all the true, right? Wherever the inequality is true. So my final answer would be -1/2, not including -1/2. That's why I have a round parenthesis, all the way to 4, but I do include the 4. Any questions about that? Does anyone know? I do not expect someone to know this answer, but I'm curious. Does anyone know, or were you ever told in your class, why does this method work? In particular, why do you only need to test one value? I mean, if you really think about it, that's a very powerful statement to make, right? That you only need to check one value, and all of a sudden you know the result for the entire interval. Do you know why we can actually do that? Or did someone tell you in your class? So, Prathana, I see you typing. I see Chia Yin typing. If I say your name wrong, I do apologize, by the way. Okay, you're just saying no. Okay. Yeah, I don't actually imagine many people would have learned. It turns out it's actually to do with calculus. It's what's called the intermediate value theorem. It has to do with continuous functions. So this function on the left-hand side is what's called continuous. We're going to learn this week? No, next week about continuity. So this function is continuous except at -1/2. And there's this thing called the intermediate value theorem that says a continuous function can change sign only where that function equals 0 or where that function is undefined, or actually where it's not continuous. So this function is equal to 0 at 4, and it's not continuous at -1/2. So the calculus tells us the only possible points where it could change sign are at -1/2, and 4. It is not possible to change sign anywhere else because the function is continuous there, and it's only 0 at 4. So the reason why this method works has a lot to do with calculus, actually. They never really told you that because obviously they really can explain the calculus in pre-calculus. But now it's kind of come full circle. Now you realize this method really does work, and it is a pretty deep reason why. Emily asked, this is not what you asked, but why do you have to test at the cut points? The only reason is because of the equal sign. My inequality has an equal sign in it. So it's possible that the cut points kind of fall right on that boundary with the equal sign. If this were a strict inequality, like if this were just less than, you would not have to test the endpoints. The endpoints are automatically false. Riley has a question. Hi, sorry, but could you explain the difference between round parenthesis and square bracket again? I think I'm kind of confused about it in the expression way. Okay, so a round parenthesis and a square bracket. So generally speaking, so this means does not include point. So a round parenthesis means does not include the point. And a square bracket means you include the point. If you're